Okay, guys, today we're going to talk about evaluating limits at x approaching infinity. What's the answer of that and how are we going to do it? The basic thing in evaluating limits is by using tables. So I'm going to choose values as x approaching infinity. Let's start by 10, 1,000, million, and so on. So if you do direct substitution here, you will get 1 over 10, which is 0.1, 1 over 1,000, 0.001, 1 over a million, 0.5 zeros, then 1. So what's happening actually, as x approaching infinity, the function or the y values are approaching to, if you look at this, 0.1, 0.001, 0.00001, so that's actually approaching 0. So what does that mean? This means limit 1 over x as x approaching infinity, or if you use negative infinity, of course it will be the same thing. So as x approaching infinity or negative infinity, the answer will be equal to 0. So actually this is for positive or negative infinity. The answer is 0 when you divide a number by infinity. And this rule is very important and we're going to use it later. So let's try to evaluate this function. Well, maybe you will think that, am I going to use a table each time? Of course not. I'm going to teach you how to do this now algebraically, and then I'm going to show you how to do it with a shortcut. Okay. As you notice here, the highest power of this function is x. So to make use of the result that we just found, we are going to divide each term by the highest power. This will give us 2 over 1 plus 1 over x when you simplify. Now, if you try to substitute infinity, you will get 2 over 1 plus a number over infinity, that's 0. So the answer is 2 over 1, which is equal to 2. Let's have a look at another example like this one. If we have limit 6x squared plus 3 over 2x squared plus 5 as x approaching negative infinity. As you notice here, the highest power is 2, so I'm going to divide each term by x squared. Let's do that. And when I simplify this, I'm going to get 6 plus 3 over x squared, 2 plus 5 over x squared. Now, if you substitute in negative infinity here, you will get 6 plus 0 over 2 plus 0 also, which means the answer is 6 over 2 only. Okay, that's good. What about this thing? Am I going to keep dividing? What is the key? Is there a shortcut? Actually, have a look at this. What's the answer here? It's 6 over 2. What were the coefficients of the highest power that we have? 6 over 2 also. Does that work all the time? Let's have a look here. What's the answer? It's 2 over 1. What were the coefficients of the highest power here? It's x, so it's 2 over 1. So again, I'm talking about the coefficients of x with highest power. So we can do this example very quickly actually. We have 8x cubed plus 5x squared over 4x cubed minus 8x. So the highest power is x cubed here. So what are the coefficients of x cubed? It's 8 over 4. So immediately the answer will be 8 over 4, which is 2. What about this one? Oh, what's the highest power here? The highest power is 4 actually. So I need the coefficient of x to the power of 4 in both the numerator and denominator. We don't have x to the power of 4 in numerator, so this means that it was actually 0x to the power of 4. So the coefficient of x to the power of 4 here is 0 over 4. So the answer of this will be 0 over 4, which means 0, since 0 divided by a number is 0. Okay, what about this case? 8x to the power of 4 over 4x cubed. Now again, the highest power is x to the power of 4. So here we have 0x to the power of 4. So the coefficients are 8 over 0. So the answer in this case will be 8 over 0. And as I showed in a different video, a number divided by 0 will always be equal to either infinity or negative infinity. So in this case, we have infinity. Actually, this is a very special case, and I'm going to talk about it in details in a separate video. Well, that's it in evaluating limits at infinity.